Accuracy in surveying is essential for construction of infrastructure. It provides accurate information for planning and design of construction. It gives information about markers and reference points. So surveying is important because it serves as a guide for the workers as to where their works are limited to. What is GNSS? GNSS stands for Global Navigation Satellite System. It is a constellation of satellite systems that provides navigation, timing, and positioning services on a global or regional basis. There are four global GNSS technologies. First is the Global Positioning System in the United States, GLONASS in Russia, Beidou in China, and Galileo in Europe. There are four GNSS criteria. First is accuracy. Accuracy is the difference between receivers measured and real position speed on time. Second is integrity. Integrity is a system's capacity to provide a threshold of confidence and in the event of an anomaly in positioning data. Third is continuity. It is a system's ability to function without interruption. Last is availability. It is the percentage of time a signal fulfills the above accuracy, integrity, and continuity criteria. GNSS consists of these equipments. First is the satellite. Satellite broadcasts a signal that identifies and provides time, orbit, and its status. Second is the receiver. The receiver is the core product for satellite positioning. Third is the supporting software. It is the applications that are used in analyzing data. There are three segments of the GNSS. First is the space segment. It consists of GNSS satellites. In order to provide the desired coverage, each GNSS has its own constellation of satellites arranged in orbits. It broadcasts a signal that identifies and provides the time, orbit, and status of the satellite. Next, we have control segment. Control segment is comprised of a ground-based network of master control stations, data uploading stations, and monitor stations. In every GNSS systems, there is a master control station that adjusts the orbit parameters of satellites. It also has onboard high-precision atomic clocks in order to maintain accuracy. Last is we have the user segment. The user segment consists of equipment that processes the received signals from the GNSS satellites and uses them to derive and apply location and time information. The equipment ranges from smartphones and handheld receivers used by specialized receivers for high-end survey and mapping applications. There are two ways for GNSS data to be acquired. First is the continuous measurements. It requires permanent installation of an antenna in a specific location. It also provides 3D measurements with an accuracy up to several millimeters. Second is we have episodic measurement. It consists of installing GNSS antenna for few hours or day at specific benchmark. It provides 3D measurements but has lower temporal resolution and more logistic requirements. Between the two measurements, when in terms of 3D measurements, continuous is way better. GNSS surveying has also its weakness. It has poor spatial coverage, so a construction site should have a clear view of the satellite in order to have an accurate data. Any form of GNSS surveying can be used in construction surveys, just like RTK or the real-time kinematic surveying. Real-time kinematic surveying uses two GNSS receivers. First is the base station receiver, and second is a rover receiver. A base station receiver samples data from satellites and transmits them together with its position via radio to the roving rover. Next is we have the rover receiver. The rover receiver receives the data and processes the GNSS measurements obtained at both the base and rover receivers to determine the positions of the rover. Machine guidance informs the operator to take action to either change the direction of the equipment or the level of the cutting edge to meet the desired design. Machine guidance not only show the operator the design difference, but also able to directly control the machine hydraulics to maintain a desired position. Machine control, on the other hand, actually controls the heavy equipment on the job site through the use of hydraulics. Digital Elevation Model, or DEM. Digital Elevation Model is a digital cartographic dataset in 3 coordinates and has derived from the contour lines or photogrammetric methods. DEM creates digital elevation data. It is used to input to quantify the characteristics of the land surface. Machine control system allows the operator to use their machineries in unison with the digital design data to perform tasks accurately and efficiently. How GPS works in machine guidance and control. GPS receivers are mounted on the outside of the machine to maintain a clear view of the sky. A separate GPS receiver is set up on a known position in the ground. This receiver is known as the base station, and its purpose is to transmit connections to the GPS receivers mounted in the machinery. Once a position has been calculated by the receiver on the machinery, it is transferred throughout the machine to determine the exact position of the machine ground braking attachments. The user interface or display is mounted inside the machine cabin. The display receives and processes all the information from the GPS receivers to calculate the machine's position. Lastly, the display also contains the design information and can compare the current and desired positions to calculate a horizontal and vertical difference. Advantages of using machine guidance and control. First is low operating cost. Refers to the fuel and maintenance, repair, replacement of blade, teeth, and tires of the machine. Next is we have lower surveying cost, since there is less taking and elimination of grade checking. Next is we have reduced material cost, since the ones that is available is used efficiently. Next is improved overall job efficiency, since the achievement of the design grade is reduced to very few workers. Second to the last is high job accuracy, specifically in millimeter precision. And last is reduced rework.